Hi, is someone here? Hi, can you hear me? Hi, I see there are two viewers. So, can you hear me now? Hi, hello, hi guys. Hi. I see there are 3 viewers. Can you hear me? Okay, I will start it. If something wrong, you cannot hear me, you can type in the chat. I will see that. So I assume that you can hear me clearly. Yeah, but no one answers me. Give me some response. Okay. Sorry for the delay. At first, I have some problems for the setup. Now I think this link works. So for this live session, at first I will give you a high-level introduction about the algorithms used in this assignment. It's the k-means algorithms and the expectation maximizing algorithms using the Gaussian mixture model. At the second, I will go through the assignment requirement step by step to make sure that you understand which part, what you should do for each part. At last, I will answer the questions that post on Piazza, also in the live chat. So you can give some questions. If you have some question, you can just write in the chat part. I will see it. Okay. So for this assignment, it's mainly about the expectation maximization algorithms. It can be for this problem is used for the classification problem. So at first I will tell you about the k-means algorithms. So I will share the screen. Sorry. So this is the ER that is included in this assignment. So it's very useful to understand these algorithms. So now you can see is yeah. So you will see this is a picture to show the k-means algorithms. So I think it can help us to understand it clearly. So I will use this example to introduce what is the k-means algorithms in a high level. So we can see that in the first 8 pictures, the green points express the data points in a 2-dimensional space. So the initial choice for the center is shown by the red and blue crosses. You can see the red blue crosses in these pictures. And in the big picture B, it is the first initial E step for the k-means. For this step, it is to divide the whole devices data points into 2 clusters. So this is an example for the k-means when k is equal to 2. So it just you assume that this data points just has 2 classes, has 2 clusters to classify. So for the picture B, it is the E step. It is the expectation step. So each data point is assigned either to the red cluster or to the blue cluster, according to which cluster center is nearer. So you can see this in the picture B. The data points that is near with the blue crosses will be the blue class, and then will turn the green to blue. And the data points that near with the red crosses, it will be the red data points. So this is the step, E step. And after this step is the subsequent M step. M is the maximization step. So in this step, each cluster center is recomputed to be the mean of the points assigned to the corresponding cluster. So we'll update the center for each classes. At first, this is just the initial center. So after I have this data points classified in the picture B, I can recompute this center for it. So you can see in the class in picture C, the red crosses and the blue crosses move into the center of the data. So the D, E, F, G, H, I. So at first, the ABC expresses the first one iteration of the k-means algorithms. So you will do a lot of iterations, and for the picture I, it's the stop point. So when we'll stop this k-means algorithms is when you find that the center position is no longer different from the last iteration. So in that position, you will see in the picture I, the data points is classified into two parts, and the center for each data point is in the center of this data points. You can see that the blue crosses is in the center of the blue data points, and the red crosses expresses the center of the red cluster is in the center of the red data points. So when you see that you cannot update the center already, so this is the stop point for these algorithms. You also finally get the two classes for these data points. So this is the k-means algorithms. Simplified, it's just two steps. The first step is to use the initial means to classify the data points. And the second step is to use the new data to calculate the new center for each class. So for this is the mean of the data points. Okay, this is k-means algorithms. For this algorithms, the next part we will use the Gaussian maximum model to do the expectation maximize algorithms. So it's similar to the k-means, since k-means is a special case for that algorithms. We also use the pictures here to give a clear understanding. So it uses the same data size to explain this algorithms. So for this time, we express each classifier not just by the center, not just the mean of this. We use the Gaussian model to express the class. So you will see in this is an example of use two Gaussian match model. The matching model means that you will use some numbers of the Gaussian model. So in this example, the number is 2. So you can, in the picture A, you shows the data points in green. The initial configuration of the maximum model in which the one standard deviation for the two Gaussian components are shown as blue and red circles. So it's figure A. For the figure B, shows the results of the initial E step, in which each data point is expressed using a proportion of blue ink equal to the posterior probability of having been generated from the blue component, and a corresponding proportion of the red ink given by the posterior probability of having been generated by the red component. So you will see that the points that have a significant probability for belonging to either cluster appear pupil. The situation after the first M step is shown in the figure C. So in which the mean of the blue Gaussian has moved to the mean of the data set, weighted by the probabilities of each data point belonging to the blue cluster. In other words, it has moved to the center of mass of the blue ink. Similarly, the covariance of the blue Gaussian is that equal to the covariance of the blue ink. So the red cluster is similar with this one. So for the next, the D, E, F, it is the iterations for after 2, 5, and 20 complete circles of the EM steps. So you can see in the F step is the stop point. You already have the two classes that is divided correctly. So for you to easily understand, you can think it is with the k-means. It's very similar, but just some small difference from that. So for the k-means, at first the true center is just the mean of the data, but in this one it uses the Gaussian model to express. So at first it just used the mean to express the classes, but now it's use the Gaussian model. So Gaussian model uses the parameters, the mean, the variance, and the maximum coefficients. So and when you do the so for update mean, it's just update parameters for the model. So for the first step, E step, you just need to classify the data points based on the two models. So this is a high-level introduction for these two algorithms. So if you want to learn more details of these algorithms, I highly recommend you to read this EM PDF that is included in the assignment. It gives you a lot of mathematics to explain this process. Also, give you some proof to make sure that this algorithm, the white is correct, white works like that. You can see more details from this PDF. Okay. For this assignment, we implement an application of these algorithms to do the image segmentation. So what is the image segmentation? I see a picture here. So the image segmentation is a kind of classification problems. So the goal of segmentation is to partition an image into regions, each of which has a reasonably visual appearance, or which corresponds to objects or parts of objects. So it's like to split the whole image into different parts, different objects. It depends on how many components you use. For example, in this figure, you can see the original image is a very clear image in the left, in the right. And when you set the k is equal to 2, so it just the blue, it's black and white, since it just has two just have two colors in this picture. So in when the key is increases, you will see the picture is more clearly. So you'll see that when you have just the two clusters, it will divided by the boy. The boy, his face is always a dark color, so all these parts will belong to the black classes. So like that. So like if you are if this a picture and have some objects, like have a whiteboard, have a door in it, and each object will have the similar colors in this object, so it will be signed in the same class. And so the different objects will be signed by the different class. So you can divide this picture into different objects by using the image segmentation. So this is the whole application we implement in these algorithms. Okay, I hope this high-level introduction give you a feel like what you will doing and give you a clear structure of this assignment. Okay, now I will walk through the assignment step by step. So this assignment, your goal is to first implement the k-means clustering, and second build the Gaussian mixture model, and 3 is to do the experiment with this model you just built, and the first part, and then do some improvements for your model, and also do Bayesian information criterion for the overfitting problems. Also, you have a bonus part. Okay, the background that I have already introduced. So the part 1 is implement the k-means clustering algorithms. So I have already introduced this. We can at the same time see the code. So at first, you will need to implement the k-means cluster method. The input is the image values, and the k is how many classes you want to classify, and give you an initial means. Then you implement the E step and the M step and also have the stop condition to implement it. Okay. This is current we provided for you. Okay, so the part 2 is implementing a Gaussian mixture model. At first, you calculate the joint probability, but in the log space. And then you use the expectation maximization algorithms to train the model. It has the E step and M step, as I introduced before. So the current condition we already provided for you is like we use that the new likelihood is within 10% of the previous likelihood for the 10 consecutive iterations. So if this condition meets, it means that the model has converged. So this is provided in the default coverage method. So you don't need to change it. Then it is the Gaussian mixture model class. You need to implement the joint prob method, initial training method, the train model method, and the segment method, likelihood method, best segment method. Okay, I will talk it one by one. So the joint problem is the first one. Calculate the joint probability in the log space. Okay, the second one is the initial training. So this one is just need to set the variance and the maximum coefficient and the mean just to set the initial value for the parameters. Okay, the likelihood is you need to calculate the log likelihood to train the model. It will be used for the convergence condition, so it is a helper method for the train model. The segment is after you have trained this model, you will need to send the result of each class to replace the original image. So the main method will implement in the train model method here. You will need to implement the E step and M step for the EM algorithms here. So the best segment method is to use for this method, you will not guarantee to get the global optimal. Sometimes since the initial parameters you choose by randomly, so sometimes you will get stuck by the local optimal. So for the best segment method, so you will do a lot of iterations, try to make that you didn't get stuck into the local optimal, and try to get the true real optimal is a global optimal. So this is the best segment method. Okay, so the part 3 is to do some experiments to improving the GMM performance. So the first you can improve is to implement the initialization. As I said before, if you just initialize randomly, so you can easily get stuck into the local optimal. So a better way for it is you change the initialization process to try to choose a better initial parameter value to train at first. Since we don't know that which is the best value for this parameter, and we don't know the model, since this is the result we want after we run these algorithms, but we want to try to find a better initial value for it. Yeah, so you can think some algorithms to do it. To make the value you use for the initial parameter is more suitable, not just randomly. Okay, for the part 3b, you can also do an improvement on the convergence condition. So for the default convergence, we just compare the likelihood, but the likelihood is not a good representation for the model. So the model is use the parameters means, variance, and the mixing coefficients. So use this to express this model seems more suitable. So you can use these three parameters to do the convergence. This is in the Gaussian machine model improvement class, and you implement the initial training, and the new current function, you write it, not use the likelihood, but use the mean, variance, and the coefficient parameters to do the convergence. Okay. So for the part 4, so it's solve the problem for the overfitting problems. So for example, if you just set each data point with his own mean, and each data point has its own model, at a very high likelihood, since each one is 100% true. You just make each point has its own class like that. But that's not what we want for these algorithms. Then we didn't meet the goal to classify these data points. But when we just use the likelihood, this may happen. So for the base information criterion, so it will, when you implement this, it will give some point for the too many parameters. Then it can avoid some overfitting. So you implement the method in this base info criterion method here, and do a test. So in the test part, you will choose which one is the optimal number. Use this image. For the part 4b, you don't need to worry about the test we use is different. We just use this same image for this test. But in the other part, we will use a different picture for the Bonnie test. Yeah. Okay, then the part 5 is just return your name, and the 6th, the bonus part, I will not talk more about it since it's just additional part. You can think about it for yourself. Okay, so I will see if there are some questions here. Okay, for the runtime problems, I see people can do it just in few minutes, but if gives you a guideline, I think as long as you can use your code can run less than 10 minutes, that must be fine. Yeah, but I'm sure you can do it more quickly than that. Okay, the local test, as I said before, just the part 4b, we will use the same pictures. In the other cases, we will use the different pictures. But I think if your implementation is good for the local test, it will not filled in the other pictures, since your algorithms is not just for special image, right? It's for the everything here. You can your implementation will be suitable for other images as well. Okay, so the test will fail sometimes. I also see this problems in other posts. So we give the threshold is 215 and 190. It's not here's the values for this part. So I see that some people can do it in like 280 and 200. So I think if your information is correct, and it should pass this. Yeah. Part 3A. Okay. I think for this one, it is this always I think this is the goal. Like why we set this part, we want you to make some improvement of this initialization. So you can use anything, any algorithms, not math. You don't need necessarily to use this natural optimization. You can also use others. If you want to use, you can learn it by yourself, since this is one of the goal of this assignment. You want to try yourself something and learn some new things like that. Yeah, to make the improvement of the initialization. So which method you use is doesn't matter. You just want to make the goal is to make a better initialization to implement the performance. Okay. Okay. So for the live chat, is there any questions here? Okay, I hope this live session will be helpful for your assignment, and good luck on this assignment. Also, you can also put the questions on the Piazza. I will respond it as soon as possible. I will wait just a few minutes. If someone has some more questions, you can just reply in the chat. I can see it. Yeah. Okay. Thank you so much for joining this live session. Have a good day, good afternoon, good morning, good evening. Bye.